Hello class, today we will be looking at chapter 3, which is displaying and summarizing quantitative data. Remember, quantitative data is data that's measured in numbers. So summarizing the data will help us look at large set of quantitative data and be able to make conclusions based off of it, be able to analyze it. Without the summaries, it's hard to grasp what the data is trying to tell us. So the best thing you can do is make a picture, like a graph. We can't use bar charts and pie charts for quantitative data since those displays are for categorical data. So we're not going to use bar charts and pie charts anymore. We're going to start using histograms now. So the chapter example they're using discusses earthquake magnitudes. And what a histogram does is it slices up the span of values by the quantitative data into equal width piles called bins. And the bins and the counts in each bin give you the distribution of the quantitative variable. Let me show you a picture of that. See, each of these little bars are called bins right here. So the bin count tells you how many of the data are in that bin. Like this is a bunch of magnitudes of earthquakes, of various earthquakes, and there's been over 200, right, nearly 200 earthquakes that are right at like 7 to 7.2. on the Richter scale. Because think about that, so this is 8 over here, so that's 7.2, 7.4, 7.6, and 7.8. Yeah, 7.2, 7.4, 7.6, 7.8, like that. So the bins, you notice they touch each other as well. So unlike in bar charts, and these are going to touch each other, the bins will touch each other. A relative frequency histogram displays the percentage of cases in each bin. So instead of saying 200, it was like 16% of them, because 200 was 16% of all of the earthquakes. And here, this is called a relative frequency histogram right here. So your calculator will make a good histogram and choose a bin width for you. You can change the bin width if you want. Now, when we get calculators, when we're back in school, I'll show you how to do that. So experimenting with different bin widths on your calculator will give you a good feel for how you can present the data differently. Like I said, we'll get to that when we get back to school and we get a calculator. The next way to show quantitative data is stem and leaf displays. It shows the distribution of the quantitative variable just like the histograms while preserving the individual values. And a stem and leaf contains all the information, and it satisfies the area principle as well. So let me show you what a stem and leaf looks like. It looks like this right here. That one right there. It split sheets 10s place, like 80s, 70s, 60s, 50s, like that. And let me show you what these numbers actually mean here for this split stem display right here. Like this list of data right here would be 56. Oh, let me go back. That would be like 56. See, there's 56. 60, 60, 64, 64, 64. That's how you read this. 64, 64, 64. So there were 3 64s, 68, 68, 68, 68, because there's 4 of them. 68, 68, 68, 68. And that's how you read a stem and leaf plot. So for stem and leaves, you cut them each data value into the leading digits. Those are the stems, like 50, 60, 70, 80. You use the stems to label the bins. And you only use 1 digit for each leaf, either a round or truncated data value. If it was a decimal place, you would use a truncated data. And don't forget a key so the reader knows the values of the stems and the leaves. We're not going to do a whole lot of stem and leaf plots. We may do a couple in class. A dot plot is a simple display that just places a dot along an axis for each case in the data. The dot plot to the right shows the Kentucky Derby winning times, plotting each race as its own dot. You can see a dot plot displayed horizontally or vertically. This one's horizontal. Most of them will be vertical. This one they happen to do horizontal. Dot plots are great for small amounts of data that have discrete values. Just like straight whole numbers usually is what you'll see dot plots, and no more than like 100 data points. So remember the make a picture rule. You always need to try to make a picture of what you're displaying, and think carefully about which type you want to make. And so before you make a stem and leaf, a histogram, a dot plot, think about the quantitative data condition. The data are values of a quantitative variable whose units are known. So you want to think about which one would make the most sense for the plot that you're trying to make.